It's another math day with teacher Jenny here, and we have simplifying rational algebraic expressions as our topic for the day. So how do we simplify rational algebraic expressions? So let's start off with simply a rational expression here. And how do we simplify this one? Now, looking at it, when you say rational expression, it's merely in the format of a fraction. Now, in order for you to simplify fraction, you must therefore take out the greatest common factor between the numerator and denominator. And for this example, our GCF here is simply 5. Why? Now, finding the GCF, if you've got a number there, you can actually make use of the factorization 3 or the prime factorization 3. So you have here 15 and the other number is 25. Now when you say prime factorization 3, you are always going to come up with a prime number as the last number on the branch of your tree in there. So since that is 3, we are going to branch out on the composite numbers like 15 and 25. They are composite because you can find other factors aside from itself and 1. So those other factors can be 5 and 3. Now 5 times 3 is 15. Now 3 and 5 are prime numbers. When you say prime numbers, they are the numbers multiplied by itself and 1. Or those are the numbers whose factors are only itself and 1. So here we have now the prime factor. So let's try to write that again here in form of a multiplication. So we have 5 and 3. Next we go to 25. 25 is with 5 and 5. And 5 is prime. So we are to write this one into exponential form. So we have 5 squared because there are two 5's in there. Now, getting the GCF among those numbers 15 and 25, we are only getting the common and the least, or common with the least exponent in there. So looking at it, 3 is not in 25, so this is out of your choices on the GCF. Now let's go for 5. 5 is with 25 in there as well. So we are going to consider our 5, but we are to consider the one which got the least exponent there, or the smallest exponent. And this time this is now with an exponent of 1. So therefore we have this one as our GCF. So there you go with the GCF. Now, once you have your GCF, you are now going to divide each of the parts of your fraction in there, simply the numerator and the denominator, by the GCF. So this is now divided by 5. So we have now 15 divided by 5 is 3, and 25 divided by 5 is 5. And there we go with our simplified rational expression. Next, we go to this one. Now, this time, it's not only a number. It is now a combination between a number and a variable in there. So this is what we call as rational algebraic expressions. Now, how do we simplify rational algebraic expressions? We can actually do that one by simply applying what we had on our numbers a while ago, simply finding the GCF. But on the common variable in there, once you see common variable on the numerator and denominator, you are to simply just subtract their exponent because that is in the rule of division or dividing variable, that you are going to subtract the exponent of the common variable in there. So doing that one, we have the number here 16 and 28. Let's try to find the GCF by simply making use of your prime factorization 3. So we have 16 will be branched out to 4 and 4, but since 4 is not prime, so we will be branching out until we get all prime numbers in there. So this is now with 2 and 2, and the other 4 is with 2 and 2. Now notice 2 is a prime number, so we are ending that branches in there. So this is now 2, We are writing this one in an exponential form. We count how many 2's are there on the branches. So we have 1, 2, 3, 4. So this is now 4. And now we are now ready to go for the next number. We have 28. So possible factors of 28 are 2 and 14. 2 is prime, but 14 is not. So we can just branch this out. This is now 7 and 2. 7 and 2 are prime numbers, so that's the end of our branching. Now this is now 2 to the power of 2 because there are two 2's in here. And then we are multiplying that to 7. Now finding the GCF, this would simply mean that we are only taking note of what is common between the two numbers. So meaning 7 is out in there because it's not found on 16. So we will be considering our 2 in there, but we are to look at the 2 that contains the smallest exponent, and that is the square in there. So simplifying this one, this is now 4. Our GCF is 4. So that means we are going to divide 16 by 4. That is now 4. And then 28 by 4. That is now 7. And then we have p here, which is common. So we are to simply try to subtract their exponent. So 2 minus 1, that is 1. So we have it here, p to the power of 1. So we have 4p over 7, or this is now equal to 47p. So they are the same. So that is now how you are to simplify your rational algebraic expression. Now we go to the next example here. Now I need you to try that one on your own so that you will get used to the process. The process actually is repeating. So you have to bear in mind that when you do the numbers, you are getting the GCF out from it. And when you do the variables, you are to simply subtract the exponent of the variables. Okay? Okay, here we have now 27 and 81. Let's try to find our GCF. For 27, we have here 9 and 3. 3 is prime, but 9 is not. So we still have 3 and 3 here. So they are both prime. And then writing that one into exponential form, we have 3 cubed. And then going on for 81, we have this as 9 and 9. And then the 9 there will be branching out to 3 and 3. And so with the other 9 in there. So we have now prime numbers. And we have that one as 3 to the power of 4. So GCF here is 3 cubed, or that is 27. So that means to say we are going to divide each number on the numerator and denominator by 27. So 27 divided by 27, it's simply 1. And then 81 divided by 27, that will now be 3. And then we are going to subtract your 5 and 3. That means we have there x to the power of 2. And then we have there y to the power of 3 and then y to the power of 1. Subtracting those two exponents, we have 2 in there. So we have our final answer here. You can actually write this one as 1/3 and then you do the variables in there. So we have your x to the power of 2 and y to the power of 2. So they are the same. Or you can simply write it as x squared y squared over 3 in there. So there you go with your simplified expression. Next we go to this one. Now this time this involves binomial. Binomial meaning there are two terms on the numerator and denominator. So if this is the case, this requires factoring. So factoring your x squared minus 1. If you don't know how to factor this one, kindly go to my channel and then look for factoring the difference of two perfect square binomials in there. Okay? Now, factoring this out, this would simply mean that this is now x minus 1 and x plus 1. And then we have at the bottom part, we have x plus 1 in there. So we simply cancel out common in here, the x plus 1 and the x plus 1. So what is left only is our x minus 1. So there you go with the simplified version of your rational algebraic expression. Next, we go to this one. And this one, again, requires the concept of factoring. And again, you can just go to my channel and then look for the factoring in there in which you have or you wanted to make use of that and learn that one on your own. So this one here at the top, you will be using factoring by GCF first. So let's do this one. So we have here common is 2. Among 2x squared and 32, the common is 2. So taking out 2, that would mean we divide each of the term on the numerator by 2. So 2x squared divided by 2, that is now x squared. And then we have 32 divided by 2, that is simply 16. That's over. Now looking at your denominator, it's trinomial. You can actually factor this out using a trial and error. You have there negative 8. You factor it out using that one. And we know that the middle term is positive. So our bigger number will contain the positive sign. So we have to start with 1, negative, and then we have the positive 8. Adding the 2, that means we have 7. That is not the number we're looking for. And then we go to negative 2, pairing that up to 4. And this is now positive 2. And indeed, this is the number that we're looking for. So our factor then is x minus 2 and x plus 4. Okay, now notice on the second factor here, this one, this can still factor it out. So we have to factor it out completely. So we start with 2, copying 2. And x squared minus 16. X squared and 16 are perfect squares. So we are to use the difference of two perfect square binomials. So we are to factor this one as x minus 4 and x plus 4. And writing along with you the denominator, which is x minus 2 and x plus 4. So canceling out common. So this is now equal to 2 times x minus 4 and x minus 2. That's it. That's the final answer. Or you can just simply do it like 2x minus 8, and then that will be x minus 2. There you go with your final answer. Next, we go to this one. This is now trinomial, so you are going to go back to really factoring trinomials in there, and 40 and 24 are not perfect squares, so we are going to look at manually our factors in there. So we have negative 40, and since the middle term is negative, so that means to say our bigger number is negative. So we'll start off with 1, and then we have the negative 40, adding that up, that is now negative 39. And then we move on to the next one. Let's have 2. And then we have negative 20. That will be equal to negative 18. We move to the next one. We go for 4. And that will be now with negative 10. So this is now equal to negative 6. But that's not what we're looking for. Let's go and continue with the process. Let's go to 5. And this is now negative 8. So this is now negative 3, and there you go with what we are looking for. So this is now with factors x plus 5 and x minus 8. Now we go for the bottom part. Bottom part is 24. Looking for the factors of that, we have a negative in the middle. So that means it's negative, negative. So negative 1, negative 24. Adding that up, this is now negative 25. We go to the next one, negative 2 and negative 12. That will be equal to negative 14. Next, we go to negative 3, and then we have negative 8. This is now negative 11. So there we go with what we are looking for. We have x minus 3, and then x minus 8. Canceling the common out. So we have final answer is x plus 5 and x minus 3. So there you go with your simplifying rational algebraic expression, and I hope you learned something from me. Now, remember always that math is a repetition process, or skills in math are repetitive in nature. So you have to do hard work in practicing so that you'll get perfect and get used to the process itself. So, again, this is your teacher Jenny signing off.